Hey everyone, who's all here? It's time for office hours. If you have questions, let me know. What questions are there right now? We got a lot going on, a lot to work on. Let me know. Adam and I are working on, if you're in 475, we're working on a video to help people out with the steps. Hello, Nicole. Great to see you here. What are you working on, Nicole? Let me know. Drop your questions in the chat, Nicole, and just let me know your questions. Jump question, Ashton. Ask away. Whatever jump questions you have, we can answer. Let me know your questions. I've got Jump here ready to go. Sorry for the delay, everyone. We were just getting things going. Abigail, great to see you here. Some 320, let me know. We had Adam joining in for some 475, and we're going to make an amazing video for 475. We already planned it out. We got a time frame. I'm very excited. So huge thank you to Adam jumping in. But what questions are there right now? Nicole and Ashton and Abigail. We'll throw out some points. We're going crazy on the points. Can we look over question 2 on assignment 2? For loops, you bet. First question of the day, some 320. Maria, great to see you here. Let's go here to BAS 320. Assignment 2, question 2. Let's go check this out over here. Oh, I've got so many things open. 2 seconds. And let's go grab that assignment. Adam says, oh, Adam, good to see you here, Adam. Are you able to look at some questions? I can kind of talk about, like, I don't have the assignments, so I'm not going to work the direct assignments, but if you have questions, let me know. I just know you don't need to use jump for this question, but you show how important the data for the homework and make a dot plot. Oh, yeah, let's do dot plot. We'll do dot plot here next. So we'll pull up the for loop assignment. We're pulling up for loops, and then let's pull up some dot plots. So here we are with the for loop assignment. Let's start off. Second question, the homework for 201 coming up here next. So the first question we have right here is on how to do the for loops for this assignment. So let's jump in here to question number 2. Now this one's really excellent because what it is basically we can see repetitive code. So how many components are in a for loop? For all related BS training, I was wondering why there's... That would be the, so that shouldn't have a comma right there, Nicole, at the end. So the comma is the second argument. And so that right there with the order is decreasing to, oh no, it does have the correct comma because that is in the row and column space. Yeah, Adam, if you can kind of allude to it, I might not solve the exact problem, but if you're wondering how certain things work, let me know your question on it. Or like, how would you do this? How would you explain this? But let me know, Adam, and we can do that after the 201. Yeah, it should have the comma. That is correct. The reason this one has the comma, and so we'll answer this right here. The reason this one has the comma is because right here, we are ordering the rows. And so everything right here is the rows. And then this over here is the columns. Does that make sense? So that is the columns and this is the rows. So we're taking all the columns, but we're only taking these rows ordered by this vector. So this comma right here is not part of the order function. It is in the sub data frame, the rows and column space. So that's actually the comma separating the rows and the columns, where this code inside of here is we are ordering the rows by the lifetime gift to UT. So does that help out with that right there? I hope. Let me know if you have more questions. But that comma is not part of the order function. It's separating the rows and the columns for the subset right there, which was created inside of sub right there. Good question right there. And so when we do this, and great questions in the chat, when we create a for loop, how many things does a for loop have in it? You're welcome, Nicole. Great question. How many things does a for loop have in it? When I create a for loop right here, how many things does it have? And the answer is up above. That's how to write a for loop, type FOR. And so how many things does a for loop have in it? How many things does a for loop have in it? Who knows? How many things does a for loop have in it? Thoughts? Who knows? How many things does a for loop have in it? Take a look up above. A for loop has this many things. Thoughts on it? We haven't thrown many points out today. 3, Abigail, you're exactly right there. Boom, right at that moment. 3. So it has a vector, a placeholder, and a skeleton. Now the skeleton, code that does not change. Vector, values, the placeholder goes through. Placeholder, variable that changes in the skeleton through the vector. So we have all the elements of the for loop now. Let's take a look. I bet we can identify some of these. Trying to figure out the GitHub dark. Oh, I know, right? It broke me, Adam. It broke me. But we're going to make... Adam and I planned out a really good video. That's why I was a little bit late to office hours. We are going to film one tomorrow night. And yeah, so we'll be filming one tomorrow night. Definitely. Definitely. And I really appreciate his time. It was really big for him to jump in. Huge, big thank you to Adam. So do you see anything up here? Maybe like a vector or something? Can you identify any of these components? I think the vector is the easiest thing to see. Do you see a vector we could go through? Now, the vector is kind of each time the code runs, because here's a code, 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 here's a code. There's a few different vectors we could go through. So there's a few different vectors we could go through. Any ideas on a vector? Like, as in, when the code runs, the first time it runs, it's this. Here's the first time it runs. And then that needs to change and become different numbers. So any idea what could be the vector? Any thoughts on this? Like, what is the vector here? What could be the vector of values we go through? So we need to be like, it starts at this, it goes through this, and then we need to somehow adjust that. What does 4 go through? What does 4 go through? That looks like a vector to me. If you look at what it goes through right here, does that 4 goes through what? What value does 4 go through? 4 goes through what value? 4 goes through... Disconnects here? 4 goes to 10, exactly. Great job, Abigail, right there. 4 goes to 10. So tell me, what if I do this? If I go right here and say value and store into here, what should 4 become right now? 4 should be called what now? Like if I want to just rerun this code, like this code runs right here. Let's create the vector x right here. And then let's run this code right here. And this code runs. But let's say I don't want to call this 4. I could just call it what? So what could I do instead of calling that 4? I could just call it what? What could 4 become to like still have 4 could become what? We could just call 4 what? So think about this. Oh, I'm on top chat. No wonder. We could just call 4 what? Like what is a placeholder we could use for 4 that instead of saying 4, we could just say this instead and it would still be 4. So that's our goal right now, is to kind of put placeholders in there that will be adjustable for us. So instead of 4, we could just call this what? Because what is 4 right now? 4 is called what? Give people a moment more, some 50 points on the line right here. What do people think? We could just instead call 4 what? So we've got something stored in the global environment called 4. So we could just change it from 4 to what? We could go right here and do this. Now here's the thing. Does it still work? It does. But check this out. Does 5 change? Yes or no? Do you see 5 changing every time the code runs? Does 5 change every time the code runs? Yes or no? Who knows that right there? This is 5, so does 5 stay the same or does it change as the code runs? Because this is the first time the code runs, the second time the code runs, the third time the code runs, the fourth time the code runs, the fifth time the code runs, 6 times, 7 times. Does 5 change as the code runs? Does 5 change every time the code runs? Thoughts on that? So we need to know, does it change? It does change. And it's always what to this number right here. It's always what to this number right here. Like there's 4 and 5, there's 4, 5 and 6, there's 6 and 7. It's always like the value, but what? It's always the value, but what? It's always the value. It's like there's 4, there's 5, there's 5, there's 6, there's 6, there's 7. It's always that value, but what? So it's always that value, because right now this is 4. But we don't want 4. How could we make it say 5? Because it's always that value, but what? Every time the code runs, it's like, if it's 4, it's 5. If it's 5, it's 6. If it's 6, it's 7. We could just do what to that to make it so it's a different value? What could we do to it to like have it be a different value when it runs? Because right now it's 4, but we want 5. The next time it runs, it's 5, but we want 6. So what could we do to that? What small change could we make instead of getting 4 to get 5? Let's see what people think. So right now this is 4 and 4, but we want a 5 over here. How can we make that a 5? What could we add to this instead of getting the value? Well, not levels. Good guess right there, Abel. Don't worry. Well, we just want to get 5. So instead of doing 4, let's just say +1. Does that make sense? So now, that's 5. So think about this. 2, how could I make this code right here which says 2? How could I make that, instead of 4, how could I make that 2? Because that's 4 right there. How could I make that 2? So use the same theory as the previous one. Right now that's 4, so how could I make that 2? So it's 4, but I want it to be 2. When it's 5, I want this to be 3. Exactly, Maria, exactly. Great job right there. We can just do -2. Great job, Abigail, also. Awesome work. And now, take a look at this. Now value is 5, so this is 6, and this is 3. It's doing the code for me. What do you think I've created right here? And this is a big day to talk about these things. What do you think I've created right here on line 76? On line 76, I've created my what? If you don't know who that is, he's Skeletor. So what do you think I've created there on line 76? On line 76, I've created my what? What have we created on line 76? We've created our what? Seems to me like this is a code that does not change. I'm not changing this code. I'm just changing this each time. That's the skeleton. You know where the skeleton goes? The skeleton always goes inside your for loop, and it never changes. Skeleton does not change. What is the name of the variable? So what is the name of the variable? Tell me the name of the variable that I'm using, which is the placeholder. So it's called variable down there. What is the name of the variable that's the placeholder? What is my placeholder in my skeleton? What is the name of it? It's called the variable, but in my skeleton, what is the variable that will change each time the code runs? So every time the code runs, I need to change what that thing is. It's going to like be manipulated. And you can kind of see up there in the code where the position of it is, of the thing that's changing, and then it has a name. What is the thing called that's the placeholder that will then be updated every time the code runs? The thing that is the placeholder that has just a thing that's going to change is the what. And this is what this does. It informs the loop what to change. It's saying when this loop runs, you will change the value of this. It's called variable right now, but we should probably call it what? What should be the name of the thing that changes? It's not 4, but what should be the name of the thing that changes? So the thing that will update and change will be called what here? So this is what we're going to change every time the loop runs. We're going to say, this will change, this will change, this will change. What is the name of that thing that changes? Every time the loop runs, we are changing what? So where's the placeholder at? Don't worry if you don't know. Don't know is a great answer if you're wondering that. We need to change the what? Wait a second more. We need to change value. Value is the placeholder. Oh, that's all right, Maria. Don't worry, 100 points. You were saying I don't know. That's totally fine. So value is the name of this. Value is the name of this right here. And we're going to be going over this tonight. So don't worry. I know people are getting a huge head start, and great job getting a head start on this. It's a tougher assignment. You're already, this is tougher. Don't worry. And I'm going to do a simple kind of coding thing right here in a moment. And let's take a look. The vector it goes through. What values do you think 4 is going to go through? How could we express 4 to 10, but as a vector? How could we express 4 to 10? It says do it for 100. So how could we express 4 through 100 as a vector? How could we express the 4 through 100 as a vector very quickly? So how could we write the vector of numbers 4 through 100? Think about that for a moment right here. Just be like, okay, I want to write the vector of numbers 4 through 100. They're like, okay, how do I do that? I need to make a vector of numbers that starts at 4, goes through 100, and gives every element. There's a lot of ways to do it. So how could we write the numbers 4 through 100 very quickly? We might try to go down here and try it, see if our code works, like we do something like that. How could we write the numbers 4 through 100? Yeah, you bet, Cora, definitely. Definitely. That's where I'm going to feel more comfortable. Yeah, I felt so bad, Cora. Thank you so much. I felt so bad with class today. Like, Adam really came in and saved the day, and we have a video plan to make tomorrow night. And we'll be going over the material on Thursday. 4 through 100, Cora. Cora saving the day right here. There we go. Great work. We're going to do a 201 thing right now, and then we're going to come back here and do some 475, Cora. So you got it. Great job, Cora. And this should do it right here. What this does is the first time the loop runs, it stores 4 into value, runs the code right here. stores 5 into value, runs the code right here, stores 6 into value, runs the code, and it loops around each time. So the biggest thing to know when making a for loop is we have 3 things to identify. We need to first identify what the skeleton is. Like maybe we want to print a word. So we're just printing a word right there. This is something we're going to do multiple times. So let's put it inside of a for loop right here. This is just an example. Don't include this on yours. And we go here to print word. Let's put a thing right here. Do not include this. Do not include this. I think some people listen to these on mute and don't hear me say, don't include this. So now, if I put right here word and change this to word, I could go right here and put a vector of words. And now, what will this do? It'll print Brian, Darren, and Emily. Because the first time this runs, word becomes Brian, and then it prints word. Word becomes Darren, and then it prints word. So what never changes, last question of the day right here, every time this code runs, what is not changing? What is not changing? This never changes when your code runs. You have to write one of these that never changes, and that's what you need to do to write your for loops. You have to write something that never changes, that has like a placeholder in it for what it'll go through in a vector, what never changes in your for loop. So this is a for loop that works. It just prints those words. What never changes in your for loop. Look up there for the hints up there. What never, ever, ever, ever changes in your for loop. You have to write this to like be like, here's my code that never changes. It's going to be the same static code that runs multiple times. So what never changes? Last question on this right here. Then we'll do a little 201 real quick. The thing that never, ever changes, here's a hint on the screen, is the what? What never, ever, 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 ever changes in your for loop. The thing that never changes is the skeleton. The skeleton never changes. And that's the inside of the for loop. That's the inside right here. This code right here is not changing. The placeholder is changing, and it's going through the vector elements. The skeleton, Maria, thank you so much. Got it right there. Great work. Let's hurry do a little 201. Ask more questions if you got them. For loops are pretty complicated. We're going to be doing them tonight, so make sure to tune in, and we're going to be doing them step by step by step, learning about them. So let's go check out some 201. It is time for some 201. Then we're going to do some, I think, 475. I think there was also a 474 question. Oh, let me scroll back up. Adam's asking, take your time, but this question I'm having a hard time figuring out. Some levels name are not valid. Investigate vector in your assignment. Yeah, don't do that. But do have the... Oh, yeah. So you want to look at the head of the levels of names. So to Adam's question, you want to run head on levels of names. So make sure to get the vector of names, then to take the levels of that vector, and then to take the head of it and see if you see anything odd. So check that out. Run head on levels names. So make sure to code that so that you can look at the head of the names of the levels, or the head of the levels of names. It's kind of the order to do it in right there. Question was on homework 2, question 2 for Stat 201. Let me make sure I get the right question. Question was, I should have written it down. So can we do homework and make a dot plot chapter 2? Let's go check that out. Okay. MyPearson. Signing in right here. And pulling up the MyPearson work. Chapter 2 homework. And let's replace. Here we go. Question 2. And let's take a look. Timestamp it. I don't even know the answer, but I want to know how to... Oh, yeah, let's do the date and the jump. Yeah, let's do that. And so let's put a timestamp in here. 1955. Stat 201. MyPearson. Homework 2. Question 2. Let's go check it out. Here we go. So the good news is Jump can do a ton of this work for us. So we have right here the number of hurricanes over a 14-year period. So in this year, there was 6 hurricanes, 4 hurricanes, 4 hurricanes, 4 hurricanes. And the important thing to do is knowing how to do a few things in Jump. That'll help out a ton. So we're going to click this button right here. I'm going to slow down. Click that button right there and go to Copy to Clipboard. Great question. When to visualize the model for the multiple regression model? Do we use visualize model? Visualize model. Check regression, checks conditions. Great question right there. Cora, use the visualize model to visualize the model. And because check regression does a check of conditions, which looks at QQ plots and other things. So we're going to copy to the clipboard right here. And we're just going to hit Control C or Command C. So Control C or Command C is going to copy that data to the clipboard for us. How are you doing right here, Ashton? Is everything looking good? This data has been copied to the clipboard. So we should have right here, go to the Dropbox, go to Copy to Clipboard, and copy the data with Control C or Command C. Now that we have the data copied to the clipboard, it's kind of floating around in the brain right now of our computer. We're going to go over here to Jump and go to File, New, Data Table. File, New, Data Table. I'll pause on this screen right here. File, New, Data Table. With File, New, Data Table, we're going to go right here and just go to Edit, Paste. Now, here's the big thing. This one did not have column names. Don't click inside of it yet. Just go to Edit, Paste. If it did, did I hit paste with column names? I think I did. And since it did not have column names, go to Edit, and I must have went down a tiny bit too far. Go to Edit, Paste. As you saw, if I paste with column names, it puts 2 as the first column name. So watch out. You want to make sure it's blue, but you don't want to have the first observation in the first the column head right there. So this was incorrect, and you should see something like this here with 14 observations. This one is 13 because the first one went there. And this was just pasting. It was not pasting with column names. So we should have this right here, and we just paste it in the data, and we're good to go. So now that we've pasted in the data, we can actually visualize it. To visualize this, we want to go to Analyze. And frankly, if you want to make a dot plot, I think you can make it with Graph Builder. So I'm going to go to Graph and Graph Builder. So if you want to make a dot plot specifically, go to Graph Builder. Under Graph Builder, we're just going to take and drag, and I think... I don't love it. I wish it was further apart. I wish it was easier to see the dots. This is a bit of a dot plot. Can I make it so it's easier to see? I'll hit done right here. I can't change the y-axis. I wish I could. Maybe there's things I can add. I don't usually do dot plots that much. Graph scans. No. This is a dot plot. I don't usually make dot plots. You can see the 2 points, 2 points, 3 points, 4 points, 2 points. So this right here is a dot plot. And I wouldn't usually make this. Show control panel. Here we go. It's got the jitter size, all these things, but I don't know if we can make it look a lot nicer. What we could do is we could just turn it into a histogram. So the histogram is going to make it look a lot nicer. Frankly, I would just make it a histogram, Ashton, right there. I'm not a big fan of dot plots, but I would probably just turn it into a histogram. I don't know if any of those are going to be really good. That's kind of the same thing. That's a bar chart, but there's a histogram that looks like that. Did it actually change the way the data looked? Kind of just click around and see what you get. And this right here is the same histogram. It changed the view of it a little bit, but you can see it's kind of got a little bit of a left skew. You can also go to, and this is the original way I was going to do it, Analyze Distribution, double-click the variable, and then you will get a histogram right here. You will also get the summary statistics. So you kind of get the extra stuff. Graph Builder lets you do kind of a bunch of different things right here, whether you want the dot plot, which I'm not the biggest fan of. Yeah, I don't think we can make it look... The jitter should separate it more. But does that make sense right there? Mine runs and gives me the answer for number 2 and assignment 2, but they are super weird and have e's in them. Ah, yes. Because I think the numbers are really big right there, Abigail. I think if you look at the vector I created right here, I think the answers are going to get super weird and get to scientific notation. So that's 7, but in scientific notation. And then the numbers start to get really pretty crazy right there. That's 10, I believe. So the numbers are going into scientific notation. Good question right there, Abigail. So yeah, right here, the histogram is going to be our view of what's going on with the data. Is that a separate one? It's bar chart, but histogram, bar chart look very similar. Yeah, of course, definitely. Great questions. And so this is the data right here. I believe we saw that one. And that's got a tiny bit of a left skew. It's unimodal for sure. It's got one mode. And then it's got a little bit of a left skew. I wish it just said little tiny bit of left skew. Wish it said little bit of left skew, not a lot. And why is it left skew? Because it's got a little tiny tail over here on the left. Oh yeah, no, knowing how to use jump is super helpful. I've got 320 students saying, like, oh, I love jump so much, I just want to use it. I'm like, well, R is even better. So which of the following best describes the center? So we just called it skewed. What is the best measure of center? Since we just called it skewed, what is the best measure of center? Since we just called it skewed, what is the best measure of center? We just called it skewed, so what is the best measure of center? Since we said it's skewed, the best measure of center will be what? Since we said it's skewed, the best measure of center will be what? Since we said it's skewed, the best measure of center will be the what? This is where you gotta be careful, because we just called it skewed. So you have to be like, okay, we just said it's skewed. The best measure of center is the what? So modality is like the central area. But mode, we don't have really as a choice. Mode's not bad. Mode's good stuff right there. The median, because it's skewed, we're gonna go with the median. So the median would be the average of the two numbers, and we could use our output to figure it out. So you could find out the median is 4.5, but it can't be 4.2, because if you have like 4 and 5, they would have to average to 4.5. So the median right here is going to be the best measure. Now it's going to ask about the spread of the data. So it wants to know the lowest and highest number, which is the range of the data. And I believe it goes from 2 to 6, if I can read properly. There's the range of the data. And then any unusual features, like any outliers, any gaps. There are no unusual features in this data. I think it's got it. Good questions right there. Ashton, if you have more questions, let me know. If you want to graph data inside of Jump, just copying it over, going to Analyze Distribution is a really great way to handle the data. And we're going to do some 475 here. Thank you so much, Cora, asking about the 475 questions. So let's see. Cora was wondering about 4C and D. Let's go check it out. Okay. Let's go work over here on 4C and D. Getting the questions up and going. You're welcome, Ashton. Drop some more questions in the chat if you have them. We don't have any questions after this, so we got time for questions. Got another 30, 40, about 45 minutes. Maybe I'm going to grab a little more food. My brain overheated in the other class. It's like, no. February 10th. I think I have that due Thursday also. Let's go check this out right here. Lots of help in the videos. Definitely be sending out advice. Can you show how to find the IQ on Jump? Definitely, Tucker. Is there a question you have if you're wondering about? We can do that next right here. You got it, Tucker. So let's write this down. I've asked this just for what Adam said. He would wait for your reply for question 2. It says, interpretation is very important, but I don't know what you're supposed to do. Yeah. So let's take a look at that. Let's take a look at both those. 28, 50, BA is 475. We're going on homework question 3. We'll do that one next. You got it, Tucker. And so let's go here to MyPearson. No, not MyPearson. Assignment 2. Question. Should we do question 2 to start? Let's go look at the question 2. Very inspiring music right now. I know. This is one of my favorite ones. So after my brain overheating, it's such a nice relaxing. Let's do this. So right now, let's look at the interpretation one real quick right now. I asked this on Discord, but Adam said, wait, my response. On question 2, it says interpretation is very important. So right here, we have find the mean. This is great stuff right here. So if you look at this, and these are some basic things right here. So for this portion, where did I put interpretations are important? You're talking about these right here because where did I write interpretations are very important? You're saying, oh, are you talking about question 2 right here, Cora? Because when we find the mean right here, which question are you talking about, Cora, specifically? Because we should be able to find these. Find the mean of the data set. I'm not going to find quite this. Let's go Q2A in the star part. For this person to find data sets. Yep. Let's run a major question. So you're talking about... are you talking about 3? A major component. Yes. No, this is Yeah, for all of these. So let's run some tests and create confidence intervals. This right here is for the next part. So you're talking about question 3, right? Sorry for the confusion on this. That's where this right here with this portion is creating the confidence intervals. Your results, if you want your results to be understood by people who haven't taken statistics. So this is where the interpretation. So sorry on question 2 and 3 right there. This is for question 3, which actually you might have been asking about earlier. This is for question 3, and you were wondering about which questions. Sorry, my eyes are just deceiving me today. Cora asked about 4C and 4D. Yeah, no, that's where I was like, I mean, we could say the mean is something like that. We could add some interpretation on this. Like, we would just want to find the mean of a vector. We can go to empty cars and take the mean of the miles per gallon. And we could add a comment, like, say, so we go to mean, and we could say, over here, we could say, oops, the mean miles per gallon is 20.09 for the average car in this data set. So it's the average car. The mean is the average car. And then so you don't have to add stuff in like that, but it doesn't hurt. And if you want to make it look pretty, you could go to the word editor and edit it in Word and see what it looks like down here. When you're going down here, where's the word? There it is right there. So you could bold your answer if you want. So you could do that for your answers where you want. This is how it'll look when it's in Microsoft Word. It doesn't hurt to add something in like that. That is not the answer, obviously, but it's not too crazy to find the mean for Survey 10 GPA. So what else do we have right here? Let's go down to, I think you said 4C or 4B and 4C. Sorry, I keep losing it. Can you repeat is it 4B and 4C, Cora? 4C and D. C and D. Let me do 4C and D. Let's put a new timestamp right here. Interpretations. 4C and D. 4C and D. Thank you so much, Cora. 3240 BS 475. Assignment 2. Question 4C and D. And we have one more question after this. So people, if you have a question, if you want to know something, let us know. And 4D. Let's go take a look at it. Here we go. So for 4C and D, we need to, and I think some people are asking about this. This is a really good thing to ask about. So we need to make prediction intervals. That is an extrapolation of the model. And you may need to check the data itself or visualize it to find out where extrapolation begins. It can be technically on either side of the model. So this is basically us reviewing a lot of the 320 work, making sure we know some of the basic concepts. So pulling out your notes, practicing these things is very important. So we need to first, to make predictions, what do we need to make a prediction? What should we create right here, which we don't have at this moment in our global environment? What do you think we need to make predictions? We would need a what? What do you think we need to make predictions? We would need a this to make predictions. What would we need to make predictions? A model, exactly. Great, Cora, great answers, 100 points. Keep it up. We need a model right here, so let's put some 4C work. And I wouldn't do it all in one spot. I'm just kind of showing how to do these things. We need to create a linear model, such as like the MT cars data frame, which is always inside of R in the background. It's a data set of cars. I'm doing very similar work, but maybe not exactly. We could predict the miles per gallon based on horsepower, and we need to go to data equals empty cars. There we go. So we have predicted the miles per gallon of a car based on the horsepower right here, and then we can go ahead and visualize this. So, whoops, we don't have reg class open. If we're going to use that function, we have to have reg class. And now we've visualized the model. So now that we've visualized the model, where might extrapolation begin? Now, this is a 201, 320, 475 concept. Very important question for every single class that's pretty much in here right now. Actually, every class I teach this semester. Where does extrapolation begin? Extrapolation is known as something that is outside the x-axis. You'll hear me say extrapolation. So when are we extrapolating this model? Cars that would be extrapolated for this model would be cars that are what or what? When does extrapolation begin for this model? It actually begins in 2 spots. Remember that? Technically, it's on either side. So where does extrapolation begin? So where does extrapolation begin for this model? Remember, it begins on 2 sides. It's anything out of the x bounds of the model. It's extrapolating your model. And visually what this looks like, I wonder, I don't think this will work. I don't think it'll work with a ggplotly. It's going to be mad. Let's go to plotly. And I don't think this will work. If this works, it'll be amazing. It doesn't like it. Couldn't find. Oh, I don't got dplyr loaded. Where does extrapolation begin? Dplyr. It's not going to work. No, doesn't like it. I wonder if that'd have been super cool if that worked. Where did extrapolation begin for that model? Where did extrapolation begin for this model? Any thoughts? Where does extrapolation begin? Where does extrapolation begin? Ah, that's all right. No worries, Cora. Good question. So here's the big hint. You ready? Extrapolation means we're making predictions outside the x-axis. So what is the x variable for this model? What is the x variable? What is the x variable for this model? So the first thing extrapolation means, and I'll write it right here. Extrapolation is making predictions outside the x-axis of our data. So HP, exactly. Our data goes from blank to blank. What does our data go from? Our data goes from blank to blank. So we've identified that the x variable is HP. So our data goes from what? Oh, definitely. Ryan, you got it. Let me write these down. We have a homework question 2 for 201 next. So let's write that down right here. And then we'll do the loop question next. You got it. Homework question 2 or 3. And then BAS 320. You're second in line. You got this. Question 4. So where does our data go from to? From low to high. Well, and so what is the low to high? What is the low to high on our data? What is the low to high about? You don't have to be perfect. Just kind of give an estimate. We could be perfect if we want. So we could summarize our data and look at the x variable and find out the answer. But what would you estimate the x variable goes from low to high? Like from like the lowest value of the x to the highest value of the x, what do you think it goes to? And I can find the answer to this by looking at a summary of it. So what does it look like the x variable goes from? And just an estimate's fine. It looks like our data goes from what? Like the just the value of the x variable, which is just this down here. That probably goes from what to what? Like what would be the minimum value and what would be the maximum for a guess? Like the minimum value of it is this. Yeah, I'd say that's a good guess right there. Yeah, look at that. Great guess right there, Cora. Perfect. So anything with predictions, remember the x's are explaining the y. So when we make predictions with x's, we will be then using the model right here to make y predictions. So if you put in an x that is outside this x bounds, you are extrapolating. So anything outside of the bounds of 52 to 335 is an extrapolation of our model. Does that make sense? So how could we make predictions? We can predict for our model doing this. Actually, is that right? Oh, that's pretty. It even gives you the car names. Cool. So this is the predicted miles per gallon of each of those cars. So don't worry about the car names so much, but those are the predicted miles per gallon for every car in the data frame. But what about if we have a car now, where now we have a car, let's say to predict, which we often call it in the notes, where the car has a value of horsepower equal to 500. So now we have the values we want to predict, and let's use our model and say new data equals 2.predict. I did a typo right there. 2.predict. There we go. Oh, I did 2.prediction. So now, this car, what's weird about this? What do you notice is weird about my prediction right here? Just think about what this means. And I predicted for 500, which is off the chart. And I said, this is what we should see. Like, that's what my model predicts for a car with 500 horsepower. So for 500 horsepower, what is weird about this prediction right here? So the car, I'm saying, what if a car had 500 horsepower? What would my model predict for it? So what's going on right here? So I visualized to find where the extrapolation would be. You'd have negative miles per gallon, which doesn't even make any sense. Also, you're extrapolating, so your model's not really meant to be used there because we don't even have data there to suggest what a car with 500 horsepower might have to see if it's accurate or not. So this is an extrapolation of the model because our model is going beyond the x-axis right here, making predictions well outside of what it was created from to predict. It's going beyond like the 335 bounds that we talked about right here. And so now we are extrapolating our model, like we're going further out on this, and this just seems wacky, right? That's just ridiculous. So this is how we can like talk about what extrapolation is, and it's when we go outside the x bounds of our model. And this is very important in time series because here's the thing in time series, which is the class, everything we do in time series when we make predictions is extrapolating because we're always forecasting the future. So we don't know the answers to the future. So in time series, we have a nice word called forecasting, and we say we just forecast, but in truth, we're extrapolating. So extrapolation will come back. Thank you, Cora, right there. Don't worry, this is my recovery after today. I really felt bad. I don't know. I just dropped the ball on the lecture, and I was like, oh yeah, well, bring it at him. He'll help out. So, they'll make a video. Do better. So, check your model to see if there's any points that have undue influence on your model. How many points are there? So, to check to see if points have undue influence, we got a really quick and easy way to do this. Checking to see if points have undue influence is going to be right here, and we can just do influential plot. So what this gives you is a plot of influential points, and can you just tell me visually how many points have undue influence? Just visually right here, how many points have undue influence on our model? Undue influence means they're really impactful on the model. This point right here has a high deleted studentized residual, which that's basically a z-score for all intensive purposes. It is a t basically. You're welcome. Yeah, and that's why I was a tiny bit late for office hours, but no, I really appreciate it. Everyone's so positive. Everyone's a lot like, this is ridiculous. As my brain's overheating. The positivity helped me stay like, it was coolant for my brain. So how many influential points do we have? How many influential points do we have? How many influential points do we have? And then we extend the assignment. So these right here are not influential. They are high deleted studentized residual, but the influential points will be up here, but there'll be another box down here if we it's just that this model doesn't have very low points. Normally the way this looks, what's another? It's WT weight, and let's see. What's it meant about? Wait. Oh, there we go. I use the same Y and X. Oh man, we're just not getting many. This has no influential points. Look at the empty cars data set. Gear. Just kind of making a crazy model. Is there really no cars that are on the low side? Well, I'll be. Okay, let's pull up a different data set and look at a different influential plot. It's classic. Height, weight. Okay. How many influential points are there here? Now, it might be hard to see. In Core, you're seeing it. Yep, Core, you do see the answer. I just made a totally different model to check for influential points. Be careful. There's a few ways to tell, and then we'll talk about what this output's showing you. This is high leverage, which means something has extreme X values. This is the part where high leverage begins. These are the bounds of normal, basically Z-scores, but they're T because we're dealing with quantitative data. Stat1 covers that a lot. It looks like there's 3, but there's actually, good guess right there, there's actually 4 points. So these right here are the row numbers of the influential points. There are 4. There's 1, 2, 3, 4. So you don't even have to worry about counting them. You could look at how many there are right here. Now what's really even better is you could take this and get this vector right here. There's the vector, and you could run right here on this. How can we find out how many things are in this? So if I want to know how many things are in this, what code could I put in front of this core to find out how many influential points there are? Because there's one in row 251, there's one in row 409, one in row 544. Those are where the influential observations are at. How could we then find out how long that vector is for all intents and purposes? How could we find out how long that vector is? What code could we put in front of that to be like, how long is that? You got it. There we go. And that's the answer. So you could check any model you want, like GPA. And if you run this on GPA, there's 2 influential points. Like it might be hard to see, but there's 2 influential points. And you can just change your variables to look at models and find how many influential points there are with these models. But it'll just tell you and report to you the values of influential points, which are points that are really pulling our model in a way that's too strong compared to the other points values. Like this point right here has ridiculous influence. The size of the circle is the size of the influence. All these points over here are basically doing nothing to our model. They're just little tiny grains of sand, and this is like the sun. So it has a very powerful impact on our model. The size of the circle itself is how influential the point is. Like that's a super influential point, and it's a combination of leverage. The more leverage you have, and the further you are away from the model, which is where you would have no residual. Residual is how much the model misses by. That's basically what combines into the idea of influence. Influence is kind of the mathematical combination of the two. You don't just multiply them because if you have, but it does kind of make sense because if you have zero deleted studentized residual, you don't have any influence. Like even these points over here are very tiny because they have no deleted studentized residual. How does that look for that core? Really great questions. But with this review, we might be doing a lot more tomorrow and Thursday on this. I don't even know what day it is because this is meant to be a review. So a lot of these skills, how was the first part of this summary here, Cora, with like finding the standard deviation? You're welcome. You're welcome. How was finding the standard deviation? How was finding these first few things right here? How did you do on these first parts right here with like, what is the bill amount for the 80th person? What row has the largest bill? What percent of people tipped over 15%? What percent of people on Friday tipped under 10%? How were those right here? Because I'm hoping those are just kind of quick, easy things. 1 and 2 were super easy, exactly. Like just like boom, 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 boom. And then you get down here and you're like, oh, now we're doing a little bit more of the stats stuff. So a little tricky. 5 right here. Create a visualization of the model. Yeah, we got this right here. I had to look back on my notes. Exactly. And that's the point of this right here. That's the point, to look back and also to just jump into office hours and ask questions. So huge thank you, because we'll probably be doing a little bit of this in class on Thursday. We'll probably been doing a little bit more of a Git to make sure we've got it down. But this is kind of meant to be like a notes review type thing, and to kind of make sure people are looking through and practicing and just asking questions, because it's not the easiest assignment. It's not the hardest, but the first 2 are just kind of like, got it. With that, let's go do some 201. Disappear real quick. Watch this. You ever have to think you have to sneeze and then you're just like, not gonna. How do you run a t-test in R? Only if it's easy to reply. Oh yeah, t.test. T.test and then put the vector inside of it. Check it out. Check it out, Corey. You got it. I bet. Tell me if you have questions. But t.test. Can you have a question for? Yeah, you bet, Ryan. I think that's we got that coming up right here. You bet. That's a great question. We're doing Stat 201 here next, and then we're doing that one. No, Cora, we don't usually do it that way. So it's such a great question. And then look, all I had to say was, t.test and put the vector inside of it. Try running that, see what you get, and then look over the documentation a little bit, and we have more than enough time to come back and talk about that. But that's such a good question. Like, how do we do the t-test? And then when you find out, you're like, oh, really? It's just t.test? It's like, yeah. Like, oh, that's easy. And if things are like, no duh, then you're on the right track. You're like, oh, wait. That's when you're really getting better at this and understanding how to use R. Like, then you can just answer your own questions. But you got this, Corey. Keep asking. Here we go. Let's go check out some Stat 201. We got right here data on football players. So we want to know how many points a team scores during their championships games. The total number of points scored by both teams is in each of the 11 championship games are given below. A lot of So when we copy to the clipboard, it's going to create a copy of this data set. And we need to hit Controller Command C. I think it actually copies it, but I like to make sure with Controller Command C. Then we're going to hit Done. We're going to go over to Jump. And with Jump, we go to anything we have open in Jump, anywhere. And then we go up to File, New, Data Table. So I'll pause right here. Make sure you have File, New, Data Table. File, New, Data Table. Now don't click inside of it yet. Once you have the new data table open, go to Edit, and then Paste. This one does not have column names, so we're just going to edit, paste. And there we go. Now this is where you should be at. You could always open a new data sheet and type them in manually, but one thing you want to check is to make sure that these are blue. I got like 60-something points. Is it both teams? It is both teams. Okay, that's not insane, but that's still a lot. Both teams, 60 points. That's like an average of mid-30 points. That's pretty big games right there. So with this right here, it has to be blue because blue means quantitative. So now what we're going to do is we need to find the median. Now, here's what I would do. I would practice solving this like I'm going to solve it on the test. What's the first thing we need to do to find the value that is the median? If we have values right here, we need to what those values to find the median value. If we want to find the median, we should put these values in what to find the median. To find the median, I would do what right here? How could we find the median in these values? First thing you do, make sure you do this. A lot of people forget. Not a lot, but some. They say, wait, I found the middle value. But we need to do this. To find the median, we need to order them. Put them in order. Tucker, great work there. And Tucker asked more questions. You've got it. I think we just have one more on the docket after this, so we got more time. So we're going to put them in order here. We're going to right-click and go to sort. And you can sort. I like to sort descending order. I think that's what I want. I'm going to sort descending. And now we have them. That works. We have them in descending order. Right-click, sort. You can do ascending if you want. And we will block the bot. There we go. So now we have it in ascending order. Doesn't matter which way you do it. But now we need to find the value of the median, or the position, I should say. Now the median is going to split it into two equal data sets. The median is going to split it into two equal data sets. The way to find out where the median is to take 11 plus 1 divided by 2. So that's the amount of data you have plus 1 divided by 2. Now you got to be careful. I made a mistake a few days ago where I took that as the answer. That's not the answer. What is the answer to what is the median? So can anyone put in the chat, what is the median? What is 6 telling me? So kind of look at my data right now and think about what 6 would be telling you. And what is the answer? So the median right now is what? That's the position. So the median would be what value right here? The median is in position 6. So with 11 numbers, you can see there's 5 numbers above here and 5 numbers below here. So 47. Great job, Core, right there. More points in the chat. And I don't know how to type. 47. Great work, Tucker. I can go out a limb right here. Make Tucker a mod. Sure, why not? And so now, here's the thing. Let's see what it asks next. Here we go. Now it wants the lower quartile and upper quartile. We never ask these on tests because there's disagreements on how to do stuff. If you do this one in jump, I think it does give a slightly wrong answer. So we're going to solve it this way. Here's the lower 5 numbers. What is the median of those? The lower 5 numbers, what is the median of the lower 5 numbers? Might work even better if I just show it to you this way. What's the median of that data set? The lower 5 numbers. We kind of got a lower 5 and an upper 5 with the median. So we're just going to look at the lower numbers. We've never asked Q1, Q3 on the test. Not a big fan of people solving it, but you can divide it into like a lower data set and an upper data set and find the middle of the lower data set. So what's the middle number on that lower data set? So all I did was say, I'm just taking the lower 5 numbers. Here's the median, and I'm going to take the lower 5 numbers, 37. So 37 is the quartile, the first quartile, which is the 25th percentile. Like if you get the bottom 50% and you go there, you get at the 25th percentile. So great job. I'll do the next one right here. Now we're going to go to the upper 5 numbers, and this would be the median right here at 56. These are the upper 5 numbers, and so 56 is going to be the higher number right there. Good to see you here, Shivam. Excellent work. And now well, that's it. Should we just do this last one right here? Should we just knock it out real quick, and then we'll do some, I didn't know if it was going to ask more or not, but that's a decent question. Good practice on it, finding the median especially and knowing where it's at. But we can knock out this last one here real quick because that was so short. I'm gonna do this last one right here. Let's do this last one right here. Let's do question number 4. And this is at the 54-minute mark and 18 seconds. Let's check it out here. So very similar sort of work that we're doing on this question. So with this question right here, we have the mean price. And this time, let's take our data, go here to the button, copy to clipboard. Now, Jump's going to make this super easy because when we copy it, we're going to hit Control-C, and then we're going to bring it over to a new data sheet with File, New Data Table. File, New Data Table. Just a new data sheet like an Excel spreadsheet. Boop. And now we're going to go to Edit and then Paste. There's no column name. Column names are things, let's say, like temperature or some other variable, price. There's nothing on here that gives a column name. All we have is the data. So let's just put the data there. Now what I might do is I might have to solve a few things by hand. So I'm going to go over here and just sort the data real quick with a right click and go to sort in descending order. Oh, not ascending. There we go. Perfect. I might do a few things, but here's the easy thing. If we want to find the mean, we could do what to all these data. So we could do this and then divide by 10. So if you want to check your work by hand, you could, because 10, we could give you 10 numbers on the test. We could give you 10 numbers on the test. That's not too crazy. So you could take these 10 numbers, do what to them, and then divide by 10. That's how you'd find the mean, like by hand. So it's not bad to know how to find the mean by hand. Like you might have to do that. We'll use technology here in a second. But you could take these numbers, what them up, and then divide by 10. What could you do? 50 points on the line right here. Just take those numbers and what them up and then divide by 10. Add them up, Tucker. You got it right there. And thank you, Tucker, one of our new mods on the channel. But we can do this right here with jump, going to analyze and then tabulate. Let me zoom in so you can see that. That's analyze, tabulate, which allows us to do a lot of the summary statistics very easily. I'm just going to take and drop this over here, and then I'm just going to drop mean on top of sum. Let me repeat the process. So once again, I'm just going to take the data column. It's just called column 1. That's why you'll see right here, column 1. We're just taking column 1, dropping it right here. And then we're going to click on mean. Yeah, Shim, I think we can. We got a homework one, and then we'll do the activity one. You bet. And then we'll drop it right here. And then there's the mean. If it wants the standard deviation, we could also add that on. You got to make sure you add it on here. And there's the standard deviation. All this stuff here. So we already have the mean and the standard deviation. Two things we're never really... The mean we might have you solve by hand. Standard deviation, we're never going to do that on the test. So don't try to do any standard deviation problems by hand. You'll just spend a bunch of time solving math that we don't need to solve. The mean is 995. There we go. Check answer. What is the median? Now, the median, I would suggest solving by hand. Now, if you get something wrong, it'll give us the right median if we want. If you get something wrong, let us know if Jump's like giving weird answers. Now, we have the upper 5 and the lower 5. Mine is actually a pretty easy one to solve because there is no middle number. Now look how there's the upper 5 and the lower 5. If we do the position of the median trick again, where you do the amount of data you have plus 1 divided by 2, which gives the position, it'd be the average of these numbers. Those numbers average to the same thing because they're the same number. So that was the position of the median, not the value of the median. We could even check it over here by going to median and dropping the median in right there and seeing it is the median value. Now it wants Q1. Once again, we don't ask this question on the test, but it's important to know what Q1 is. If we have a lower set of 5 numbers right here, a lower set of 5 numbers, because remember we have an upper 5 and a lower 5, what is the median there? So Shivam, Tucker, what is the median for 50 points or of that lower data set? So that's the lower 5 numbers. What is, because I'm just cutting this in half, and Q1 is going to be the middle of the bottom 50%. So what is the middle of the bottom 50%? What value is it? What is the value for the middle of the bottom 50%? Because you go, exactly 650. Great job. Check answer. And then we do the same exact steps right here, but for the higher. So let's make this window a little bit smaller. And then we go to the upper numbers right here. There we go. And there we go right there. So now the middle is this number. It's right there, 1300. Ooh, what am I doing? And now it probably wants to know, oh, the range. Well, the range is going to be the max to the min. So we can look at the range pretty quickly over here. The range is going to be 550 to 1480. So we subtract those numbers to get 850. Just subtract 1450 minus 1400 minus 550. And now the IQR. The IQR is just like the range. But the IQR is not the max to the min. It's the Q3 to Q1. Because if you have 4 quarters of your data, it's the inter 50%. Going from the 25th Q1 to the 75th Q3. And so we just take the numbers here. It's just the distance. Those two numbers are away. It should be 5. Oh, it's 1650. It is 1650. If there's an odd amount of numbers, how do you find Q1 and Q3? So in which one are you working on? We could do that one here. Which one are you working on? What does your problem start out saying? We won't do it on the test. And so the good news is you mainly have to know the idea of what Q1 and Q3 are for interpretation purposes in box plots. We'll do box plots in chapter 4. So we don't really have to worry about it. If there's an odd number like this, then Q1 and Q3 are oftentimes like down here on the lower portion. This is where Q1 is at for that. If you have a specific question, let me know. We're going to hop over to some 320, but check it out. Start up some 320 here. Okay, it is time for some 320. Let's take a look through 20. Tucker, drop those questions in the chat. Let me know, and we could work a specific one if you want. 320. Assignment 2, question 4, and Shivam had a question 2. Activity, number 4 on the activity quiz. Yep. Let me put that here. Activity 2, question 4. Okay. Timestamp on this is 1 hour and 1 minute. Okay, let's get the activity pulled up. Is that the activity? Assignment. Here we go. Oh, no, we're doing assignment first. Question number 4 on the assignment. Oh, let's go check it out. Here we go. Do we get any drops on the... I think we have one. I'll double check. I believe so. Definitely look at the syllabus, and I can double check here in a moment. I'm always afraid to say off the cuff if we have drops. Because if I ever say it wrong, someone will be like, wait, Brian said this. And I'll be like, oh, no. It's like trying to remember, like, which class has 1 drop here, which class has 2 drops here, which class has no drops. Because I've definitely misspoke. And especially on classes where there's a bunch of us teaching it, I don't want to misspeak. Do you want to see my code for assignment 2? Yeah, definitely. DM me it on Discord. DM me it on Discord. Okay. So we have right here a forecast function. And so it's important we know the elements of a for loop right here. When it comes to the elements of a for loop, how many things are in a for loop? How many things go into a for loop? A lot of this is going to be covered today. How many things go into a for loop? How many things are in a for loop? So who knows that? How many things are in a for loop? Go back up here to the start. Has some help and review right there. How many things are in a for loop? How many things are in a for loop? So how many things do we have in a for loop? Very important to know every single time. Every single time we create a for loop, how many things go into it? Who knows? Got some points, yeah. Who knows? For loop has this many components that we need to identify and write each one of them. The for loop has how many components? Oh, see what people say. So definitely use the screen for a hint. The for loop always has this many components. We need to know each one in depth, know what it does, and then be like, okay, this does this does this. I need to put this for there, and this is what this needs to be. How many components does a for loop look to have? I'll answer the question. A for loop has 3 components. A for loop has 3 components. It has a vector, a variable, and a skeleton. So we see here a vector, a variable, and a skeleton. So interestingly enough, we need a code that does not change right here. This code is not changing. So what is this code going to be? This code that is not changing is our what now? So this code that does not change is going to be our what? Any ideas what that? This is going to be our code that does not change every time the loop runs. It's just going to run this code every single time. So this code that is not changing right here is going to be our what? This is our code that does not change. So it is 3. Well, you might be answering the previous one. This is part 3, actually. It is the skeleton. So this is the skeleton right here, the code that does not change. Does that make sense, Ryan? That's the code that does not change. So this is our code that's not changing each time it runs. It's just going to run this code each time. And now we need to identify, because this is already written for us, do you see a variable in that code? Something that's a placeholder that could change, like some sort of value that we could change. This is the vector n. This is position t. This is rounding times 0.5 times the vector n, position t minus 1 plus the square root of vector n, position t minus 2 plus the log 10 of 1 plus the vector n, whatever is in position t minus 3. Do you see some sort of placeholder that doesn't have a value in it currently that could change? Do you see anything in that code that's like a placeholder for something we could input for maybe a position or something that we're looking for? Like, is there a placeholder in that code? A placeholder that currently exists in that code that could be something we could adjust and manipulate? Is there a placeholder in that code? Something that isn't a value yet currently. So we have the vector n, and we have the position t. I don't see position t anywhere else, though. It's not like I've defined t in my global environment. I can define the vector n. So do you see a placeholder of something yet to be defined that could be changed and manipulated to go through different values? Do you see a variable that we could use? So variable is just a name for the placeholder. And then we need to assign that it says, hey, this is your variable right here. Who knows what the variable would be? Anyone think it over and be like, what is the variable going to be? So good guess right there, Ryan. Good guess. N is the vector. N exists. But we're going to go to position T. T is a position not defined over. You see, there's no T. So T is the placeholder. What we want to do right now, and here, I'll go down here and show examples. If I go right here and do the following, what is the placeholder in this code right now? What is the placeholder in the code that I've just written right there? What is the placeholder, which is in my skeleton? So you can see right here, the skeleton, the code that does not change. The placeholder will go inside the skeleton. This does not change. The placeholder will change. The placeholder goes inside the skeleton. What is my placeholder called right now? So my placeholder is called what right now in this code? It's just a placeholder, just holding the spot for it. It's inside the skeleton. It's just part of the skeleton. My placeholder is called what in that code? What is my placeholder called? My placeholder in code right there is called what? The placeholder has been called just the name of it. Whatever I called it, just like that's called this right there. Placeholder was called, who knows? Get a second more. Take a guess. We'll throw out some points. Whatever you're thinking. It's like, maybe it's called this. Don't worry about it. 100 points, any answer. That's what people say. The placeholder in the lines of code that I'm highlighting right here is called what? What is the placeholder? Placeholder is called number. It's called number. So number is just a placeholder that is used down here in the skeleton. And then when we do this right here, we can go through a vector of numbers and print those numbers. So this is the vector right here. And the vector is the values that number will become every time this runs. So when this very simple loop runs right here, this very simple loop will do the following. It'll go right here and it'll run. And the first time it runs, it stores into number 1. And then it prints number. But then it loops back up to the top and number becomes what? On the second run, number would become what? Who knows in the chat? On the second run, or the first run, number is 1, and then it prints number, and then it loops up to the top, and then it changes the value of number. So the number changes. Like it's literally going right here and saying the first time it runs says number, and then it saves into number, it saves in 1. And then it runs the skeleton, which you see right there. It prints number. So good guess right there, Ryan. You're talking about the previous one. I think people might be behind in time. Maybe I'm lagging today. Great answers right there, Ryan. That is correct. Number is the placeholder. And it's going to print number. So then it prints number right here. Number is actually capitalized. Got to be very careful. So it prints number, and then it goes back up to the top, and it stores into number. It stores into number 2. Should we type out the skeleton in our code? I would not type it out. I would copy paste it. So since the skeleton's already pre-written for us, now we don't want these quotes around it. I wouldn't type it lest we make an error typing it. I would copy paste it or take from the chat. Corey, good question right there. 5C. I think we might. Just might barely have enough time. We'll try to do, we have Shivam's question next. We might have to do that one tomorrow, Corey. We might have to because I'm going to grab a little bit of food between class or between office hours and class right here. We'll see if we got enough time. But if we don't, we'll definitely do it tomorrow. So now think about this. It says when we run this vector, we need to create elements 4 through 20. So how could we tell this loop to create elements? Thank you, Cora. No worries. Thank you. How could we create elements 4 through 20? How could we say, use T, but run through the elements 4 through 20? Like, what could I change this to? So think about 4 through 20. What could I change this to right here to make it go from 4 to 20? So like I want T to take on the values of 4 through 20. So when this runs, T becomes 4, then it runs the skeleton, then T becomes 5, then it runs the skeleton, then T becomes 6, then it runs the skeleton. And so it just keeps looping through and it goes from 4 to 20. So how could we write some sort of code right there to be like, it needs to go from 4, starting at 4 to 20. Now there's a few ways to write it. We can use one of the tricks down there on like line 146. Great job, Shreya, great work, excellent work. 4 to 20. And there we go. Excellent work. Now be careful. Don't add in these extra things. You will get excessive output. Don't code everything I code. Don't directly take. Don't code everything I write. Don't put that. That's not part of the assignment. Sometimes I add extra little things. I've had a lot of people just write down exactly what I do. Sometimes they turn off the video or the audio. And I'm like, no. Write down things. Let's see. Shivam had a question. Then we might have time for Cora's activity. Let's go over here. And that should do it. We got... Oh, we need to maybe look at the tail of it. Double check at the end. It says print out the contents of the vector end of the screen. You're finished. Should see the 8 numbers. And there's the content of the vector. And there we go. So make sure to print it. You don't have to write print around this, but that'll print the vector right there. Just make sure to do everything it says. Sometimes I might get most of the work done, but check each thing. If I'm doing some of the work right here, make sure it does everything you want and don't include like sometimes include these things. Include what it asks. So make sure to read over what the question says. And if the question says to print what n is, then you need to go in here and print n like this, but don't include things like this because that's just extra fun work explaining the concepts. Let's head over here real quick. Okay, let's start up. Shivam, thank you so much. I think you asked this yesterday also, or maybe this morning. So let's just jump into the activity. I appreciate you joining back in. And you were asking about question number 4. Okay, let's take a look at some product categories right here with question number 4. So right here, we're looking at different products and whether or not they failed. So when we do this right here, how many products do you think we'll examine first? If we want to write a for loop to examine different products, and we want to examine 4 different products, that's a repetitive task. So how many products should we examine first? How many products do you think we should examine first if we want to examine different products? How many products do you think we will examine first? Kind of gives a hint right here. How many products will we examine first if we want a for loop that examines 4 different products? We should probably write a skeleton that just does what? How many products? 1. Shreya, excellent work right there. You're right. We're just going to do it on 1. So let's think about this. Kayla, you know, we're just getting into on one specific case right here. So let's see, we got the product database. Whoops, cancel. I think I've got some sort of install or something on here. Let me check. There's install. That's what's causing the issue. And let's go back to here, question 4. Run all code above. Let's remove this. And let's run the code. Where's question 4? I lost it. Question 4. And there we go. And it's under, it's the product data set. So there it is right there. There's the product data set. Make sure you have reg class running with library reg class. And then we have the product data set. If you don't have reg class, make sure to do install.packages reg class. If none of this is working, reach out immediately and say, things are not installing, things are not working, and we will get them working, we will get them installed. So now that we have this, we can actually answer the question right here, and there's the product failures. We're not going to do it that easy way, though. We're going to do it the hard way. So the aggregate function actually lets us look at some y based on some x for a data set using a function right here, and this is actually finding out if the mean, or doing a logical test for the mean equal to this. It's a custom function right there. Really great work. I think Dr. Petrie coded that. But here's the thing. Let's just find out if it's working for product A. You know what's really interesting? We can actually steal some of this code right here. Let's go and take some code right here. So I'm going to do this a different way today. I'm going to use this mean function right here. If it'll let me take it. Oh, there it is. So we're going to take this right here. And we're not going to use the custom function. We're just going to use the mean of x, but we don't have x yet. So we don't have x yet. How could we only get product A? How could we only get product A? We probably need to make a what to get just product A. So we got here the product data set, and we've got the category. And if we just want product A, what do we have to get? We probably need to make a what if we just want product A right here. Probably need to get a what. Probably need to get a what. If we just want product A, we probably need to make a what of this data set. We want to take just a portion of it. We want to make a what of it. To get product A, we probably need to create a what? Close, close. We want to make a subset, right? So let's make a, I see what you're saying. We might be saying position 1 right there, and the levels vector is product A. But let's make a subset. So let's go here and say subset of the product data set. And then let's put in a condition that says category equals to A. And take a look. It does look like we just got product A, right? Now I should store this. And now we've created a subset of just product A. Now we've created a subset of just product B. Now we don't have this called X anymore. This should be called X what? So what should we do right here? X what? So it's no longer called X because we're not going to see if X is equal to fail. We're going to see what? If sub, because we stored it into subset, and what right here? Let's see what. Let's find the mean, or like find the on average how often it failed, but we need to go to the what? You can see it over here. So what should we go to? We'll basically have it. We're almost there. So close. Oh, close, close. Not category this time. Shreya, great work right there. Don't worry. We'll go to outcome. And that's going to give us the, yeah, you got it. That's excellent recovery right there. Go to outcome. And so think about this. Notice this. I can find it for A. I can find it for B. I can find it for C. What do you think I should replace this with? Since this is changing, what do you think I should put in here? Let's go grab our helper code. What do you think I should put for, instead of a, I should put a what for like A, B, C, D? I should put a what right there. What do you think I should put for there? What do you think I should put right there instead of A, B, C, D? I should probably put in a what? What should I put there for that? Look at the options we have. Should we put a skeleton? Should we put a variable? Should we put a vector? What should we put? What should we put there? Should we put a skeleton, a variable, a vector? What should we put right there? Skeleton, a variable, a vector. Not a, so this will become the skeleton. More points, don't worry. This will become the skeleton. And so no, don't worry, like skeleton, no. But so it'll become, this is the variable. The variable is a placeholder to change something in the skeleton. Does that make sense? So the variable, and don't worry, this is the practice. We'll be going over this today in class. The variable is the placeholder. So let's call this level right here. Levels is kind of, let's call it category chosen. You can call it whatever you want. Anything you want. Yeah, no, don't worry. This is the practice. And so this is now our skeleton. He's here. We found him. We've written a code that doesn't need to change. We've created our skeleton. He's so happy right there. So now that we've created our skeleton, this gets to go inside the for loop. So we drop it right here inside the for loop. We highlight the code and hit Control-I to reformat. Makes it look nice and pretty right there. And so now we can actually see this. We could print these out. We'll do that for the moment, just to print the answers. And the variable is category chosen. That's what's going to change in the code. And then it needs to go through, and I think they mentioned this up here, the levels of the products. So this is actually the vector we'll be looping over. It literally says right there, the vector we're looping over. And those are the answers. Now, you could, like, watch this. Here, we'll do it a different way. I have to go in a second. Cat, paste. We'll do it the official way. It's called prod fail. I'll do it the way the question says. We need to initialize the vector. If you're going to store into something, you want to initialize the vector. And there's a blank vector for us to store into. Let's store into this vector, into position, category chosen. And let's remove the extra parentheses because we don't need them. And that should work. And there you go. So, and this is really great right here because with this vector, we can do vector mathematics on it. Let me send out the announcement to everyone. We'll be starting here in just a moment. Class in 10 minutes. Whoa. As Joey would say, whoa. Some old school TV right there. Class playlist. class in 10 minutes. Send out the announcement. How is everyone doing? An excellent work today. Lots of office hours. So class in 10 minutes. Big lecture. 4 loops. Oh my gosh. Big learning objectives today. See you soon. Click here. Okay, so there we go there. Send out the link. And we'll start that up soon. Oh, thank you. I did the last bit here a little bit quickly. I try to take it slowly, but I'm going to go grab some food real quick. So grab some food yourself. I feel like I should grab another cup of coffee or some, I don't know. Maybe I shouldn't have caffeine. With that, we'll be starting up here shortly. I'm going to grab a little bit of food. I'll see everyone soon. Bye for now. I found out the rainbow parentheses. Yes, it's so pretty, isn't it? Just follow the rainbow right here to the parentheses. It's so nice. If you have questions like that, let us know. You can tell where things close and end with the colors of the rainbow right there. It's so much fun. It's so nice. It's so beautiful, right? You start opening up and closing parentheses, and you're like, open, 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 and you just get the colors of the rainbow. You just want to make a rainbow. Just imagine a little kid right here says, I'd love to see the rainbow. Sure, right there. That's awesome. I love those things like that. See you in class. We'll be here soon. Bye for now, everyone. Bye!